Okay, so to leave off where we were in class today, we were solving for extraneous solutions in absolute value equations, and then we're going to move on to inequalities. So we said the first way to start off in this equation was to separate it into two equations. So 3x plus 2 equals 4x plus 5, or 3x plus 2 equals the negation of the other side. So negative, and then the quantity 4x plus 5. So we're going to solve regular equations. So we're going to subtract the 3x to one side. We get that 2 equals x plus 5. Subtract the 5. And we get that x is negative 3. And we know that you can write it either way. Usually the variable should go on the left, but it doesn't really matter. So x equals negative 3, or we're going to distribute the negative sign. So we get 3x plus 2 equals negative 4x minus 5. We can add the 4x to the other side. So we have 7x plus 2 equals negative 5. Subtract the 2, and we get that 7x equals negative 7, which when we divide by 7 gives us x equals negative 1. But now we need to check both of these. So we plug it into the original equation with the absolute value symbols there. So the absolute value of 3 times, we'll do the negative 3 first, plus 2 equals 4 times negative 3 plus 5. So we get the absolute value of negative 9 plus 2, which is going to give us a negative 7, equals negative 12 plus 5, which is going to give us a negative 7. But the absolute value of negative 7 is positive 7, and positive 7 does not equal negative 7, so this is an extraneous solution. Normally the question will ask you to label the extraneous solution. This one is extraneous, which means it's not an answer. Now we need to check the other one. So we're going to check negative 1. So the absolute value of 3 times negative 1 plus 2 equals 4 times negative 1 plus 5. So negative 3 plus 2, which is negative 1. So the absolute value of negative 1 equals negative 4 plus 5, which is positive 1. Well, the absolute value of negative 1 is 1, so this one works. So x equals negative 1 is the only solution. X equals negative 1 is the only solution. This is extraneous. It will ask you to label it as extraneous, but x equals negative 1 is the only valid answer here. Moving on, still in this section, is absolute value inequalities, and this is where it gets a little bit different. So I like to think of goal. When it's greater than, it's or. When it's less than, it's and. So greater than is or, less than is and. So we're going to be creating compound inequalities because it's an absolute value inequality. So when it's greater than, it's going to be a compound inequality using the word or. So we're going to set up two inequalities. One without the absolute value symbols again. So we have 2x plus 4 is greater than 6, which is the same as we had before. And then we have 2x plus 4 is less than. Now we're going to use less than negative 6. So we just change what's not in the absolute value symbols to a negative again, but the sign also is different. So this is again for when we're using or, for when it's greater than originally. So we're going to solve the two absolute value inequalities. So we subtract the 4. We get that 2x is greater than 2, which means that x is greater than 1. Or we subtract the 4. we get that 2x is less than negative 10, which when we divide by 2 gives us that x is less than negative 5. So this is our compound inequality solution. Now we need to graph it. So greater than 1 is an open circle at 1, and then we're going to have a straight line with an arrow at the end of it. And when x is less than negative 5, it's an open circle at negative 5, and less than is going to the left. And you can see again, or they're usually going in different directions, which they are in this case. Now, a separate example, we're going to try the absolute value of 2x minus 1 is less than 5. So we're going to start off by creating our two inequalities. So 2x minus 1 is less than 5, and because we're starting with less than, it's going to be and 2x minus 1, change the sign and negate it, so is greater than negative 5. We're going to solve the two inequalities normally, so we're going to first add the 1 to the other side in the first inequality. So 2x is less than 6, which when we divide by 2 gives us x is less than 3. And we add the 1. 2x is greater than negative 4. Divide by 2, so x is greater than negative 2. So this is our compound inequality algebraically. You can also write your answer whenever it's using the word and by doing an x in the middle, and it's less than 3, but it's greater than negative 2. And you can see when you're reading it in reverse, it does say x is greater than negative 2. This, whenever you see a compound inequality written this way, it automatically means it's using the word and, but this is kind of the easier way to think of it when you're graphing it, because if you're graphing them separately, x is greater than negative 2 is going to be an open circle at negative 2 going to the right, and it's less than 3 is going to be an open circle at 3 going to the left. Where they overlap is the answer. So it's easier to think of it as a compound, like we have here, written all as one big inequality, because you put an open circle at negative 2 since it's just less than 3, and since it's just greater than negative 2, we're going to put an open circle at negative 2, an open circle at 3, and just like it looks like here, x is somewhere in between those two. So when you're using the word and, you can write the compound inequality like this once you get your final solution. Please make sure that you have your textbooks for tomorrow when we start group work. Bring any questions that you have to class right at the start so that you can really get working on those questions together. And if you're in a group of 4 or you're in a larger group, please make sure that more than one person has their textbook. That way you can all follow along at the same time.